I would like to present 3 essential trace minerals that have the potential to reverse alopecia, a significant autoimmune disease causing hair loss on the scalp. Similar autoimmune conditions like Hashimoto's and lupus can also lead to this outcome. How does a deficiency in trace minerals contribute to hair loss? Despite their minimal requirement, these minerals possess a remarkable influence on the body. They play a crucial role in preventing and treating autoimmune diseases, as well as directly contributing to the development of hair protein. Proteins, commonly associated with muscles, are not limited to that function alone. They encompass various types found in the human body, including enzymes. These enzymes are involved in essential biochemical processes, such as hormone synthesis and overall thyroid function. Specific enzymes are responsible for producing body tissues associated with thyroid hormones. Additionally, certain enzymes convert the inactive thyroid hormone, T4, into the active form, T3. Furthermore, proteins within the immune system play a vital role in maintaining its strength, preventing self-attacks, and inhibiting the production of antibodies targeting one's own tissues. And among all the minerals, there are 3 trace minerals that hold significant importance in ensuring a balanced diet and understanding factors that contribute to deficiencies. Let's begin by discussing iodine. It's widely known that iodine is essential for synthesizing thyroid hormones through enzymes. Insufficient iodine levels result in the inability to produce these hormones. While some data suggests a potential link between excessive iodine intake and autoimmune diseases in individuals with thyroid problems, overwhelming evidence refutes this claim. In reality, it is usually a deficiency in iodine that poses a greater concern than an excess. The average person tends to lack iodine due to its scarcity in our food, primarily because it is not abundant in our soils. Unless individuals consume sea-based products, it is unlikely that they obtain adequate iodine. Exceptions include those who incorporate sea kelp or seaweed into their diet, or individuals residing in regions where seaweed consumption is common, although this is not the case in America. Sea salt is our primary source of iodine. However, it is doubtful that we acquire sufficient amounts to meet our needs. When iodine deficiency occurs, estrogen levels can spiral out of control, as iodine helps regulate estrogen. Inadequate iodine combined with excessive estrogen can lead to ovarian cysts, fibrocystic breasts, and even nodules on the thyroid gland itself. It is worth noting that iodine deficiency can occur not only due to dietary factors, but also as a result of other substances hindering iodine absorption, such as fluoride. Whether it be dental whitening treatments or consuming tap water containing fluoride and chlorine, both these substances interfere with iodine. Another interference comes from bromine, commonly found in enriched flour products like bread, pasta, cereal, crackers, and biscuits. However, since you are a follower of my channel, you are likely avoiding such foods. Interestingly, fluoride can also be found in unexpected sources, including approximately 20% of all medications, such as Prozac, statin drugs, certain antidepressants, antibiotics, antacid medications, and anti-inflammatories. These medications contain fluoride, which can disrupt iodine absorption. Regarding the recommended daily intake of iodine, I would suggest approximately 200 micrograms, not milligrams. Adequate iodine intake is especially crucial for children during their growth phase, as iodine deficiency can lead to various cognitive impairments. Sea kelp, seafood, and sea salt are all beneficial sources for increasing iodine levels. Moving on to the next trace mineral, zinc plays a vital role in supporting the immune system. In cases of autoimmune diseases, zinc deficiency is commonly observed, contributing to an imbalanced immune response. The most bioavailable sources of zinc are derived from meat, fish, and eggs, while plant-based sources are not considered reliable sources of zinc. Excessive consumption of cereal is one of the primary culprits behind zinc deficiency. Cereal, like other grains, contains phytates that inhibit mineral absorption, particularly zinc. Zinc plays a crucial role in supporting the immune system, and its deficiency makes individuals highly susceptible to infections, inflammation, and other health issues. Furthermore, zinc is directly involved in the function of certain enzymes, which are essential for hair growth. When considering zinc supplementation, a recommended dosage would be around 50 milligrams. However, if you consume foods like red meat, beef liver, oysters, or seafood, it is likely that you are obtaining adequate zinc from your diet. Nevertheless, exposure to mercury can increase the body's demand for zinc. Additionally, high sugar intake or chronic stress can significantly raise the requirement for zinc. Moving on to selenium, this trace mineral is involved in the functioning of 35 different proteins, primarily those enzymatic proteins responsible for various bodily processes. Selenium deficiency can result in premature graying of hair, alopecia, or even Hashimoto's disease. However, selenium intake requires a delicate balance as both deficiency and excess can contribute to alopecia. Mercury also interferes with selenium absorption. Many pregnant women are deficient not only in selenium but also in zinc and iodine. This underscores the importance of supplementing with trace minerals during pregnancy. It is worth noting that certain genes influence selenium absorption, and genetic mutations can hinder adequate selenium uptake. In such cases, even with the minimum recommended intake, deficiency symptoms may persist. Genetic testing can be conducted to identify such mutations. I have been extensively exploring the topic of DNA and its relation to minerals and vitamins, particularly concerning B12, folate, vitamin D, and vitamin C. I plan to delve deeper into this subject in future videos, as many individuals experience genetic challenges related to nutrient absorption. Another fascinating aspect of selenium is its role in regulating vitamin E levels. Selenium helps prevent vitamin E deficiency by acting as a precursor for glutathione, a powerful antioxidant, and other antioxidants as well. The recommended daily intake of selenium typically ranges from 50 to 200 micrograms, which is a relatively small amount. Just one Brazil nut can provide the necessary selenium intake. However, it's important not to overconsume, as toxicity can occur fairly quickly. There are other nutrients that significantly impact hair health as well, and I'll quickly touch upon them. Iron and B12 play a crucial role due to their ability to enhance oxygen and blood levels, specifically to the scalp. Without adequate blood flow and oxygen supply, hair roots cannot thrive. One common reason for iron deficiency in women is menstruation. If that's the case, I have provided a link below that offers guidance on addressing this particular issue. Regarding B12, deficiency may arise from a vegan diet or genetic factors related to methylation problems. You can find more information on this topic in the link provided. Vitamin D is highly important, especially for individuals with autoimmune diseases, as it helps reduce inflammation. Although vitamin D deficiency itself does not directly cause alopecia, it can lead to the loss of body hair, which is a form of generalized alopecia rather than limited to the scalp. If you have any autoimmune condition, it is advisable to take daily vitamin D supplementation, typically around 20,000 IUs. Let's briefly discuss biotin, also known as vitamin B7. Many people tend to take biotin in large quantities. Biotin plays a crucial role in protein synthesis, particularly in relation to hair and nails. When deficient in biotin, hair becomes dry, frizzy, and prone to shedding, often resulting in general hair loss. There are a few reasons why individuals may experience biotin deficiency. Firstly, biotin is produced by the gut flora, so factors such as antibiotic use can disrupt its production. Secondly, consuming raw eggs can lead to biotin deficiency, as a compound in raw eggs can bind to biotin, limiting its availability. However, it's important to note that the yolk of the egg contains the highest concentration of biotin. Additionally, pregnancy increases the demand for biotin, which may lead to deficiency. Lastly, some individuals may have genetic variations affecting the absorption of biotin due to issues with specific proteins. In such cases, a slightly higher intake of biotin may be necessary. Now let's touch upon folate. Interestingly, folate deficiency is relatively common despite its presence in dark leafy green vegetables. Many people have a specific gene variation called MTHFR, which necessitates higher folate consumption, specifically folate and not folic acid. This genetic variation impacts the ability to build various proteins, including those necessary for healthy hair.